In this video, we will be discussing about special array 1. An array is considered special if every pair of its adjacent elements contains two numbers with different parity. You are given an array of integer nums. Return true if nums is a special array, otherwise return false. So in the input, we are given an integer array nums. Now we need to identify whether this particular array is a special array or not. Now what do they mean by a special array? So if in an array, every pair of adjacent element has different parity, right? Then it is a special array. If any pair has the same parity, then it is not a special array, right? So we need to return true if it is a special array or false otherwise, right? Now, what do they mean by parity? So basically they mean that if I consider these two adjacent elements, then one of them has to be even and one of them has to be odd, then they will considered as having different parity, right? If both are even or both are odd, then they are of the same parity, right? So simply what we need to check is that in this array, for each of the adjacent elements, one of them has to be an even number and one of them has to be an odd number, right? So if we see this is even, this is odd, so this is okay. Then let's check next pair. This is odd, this is odd. Now both are odd. They are having same parity. So then that means for this, our answer will be false. Then if we check for the next case, even, odd, odd, even, odd, right? So here our answer will be true, right? So now how are we going to solve this? So it is very simple. We can simply put a pointer I on this particular index. If I give the indices 0, 1, 2, 3, so we can start our I from the first index and we can always compare nums of I with nums of I minus 1 because these will be our two adjacent elements, right? And then for checking that one is even and one is odd, what you can do? So see, when we do the modulus of an even number with 2, we get a 0. And when we do the modulus of an odd number with 2, we get a 1, right? So then that means whatever is your nums of I and whatever is your nums of I minus 1, if I do their mod with 2, then whatever is the result, that should not be equal. Because if both of them are giving a 0, then that means it is even. If both of them are giving a 1, then that means both are odd. So these should not be equal. So this is one way of checking. Now other way of checking is that when we do the sum of two odd numbers, we get an even number. When we do the sum of two even numbers, we again get an even number. But when we do the sum of one odd and one even number, then we get an odd number, right? So simply what we can check is that the sum of nums of I plus nums of I minus 1. Its modulus with 2 should give you a 1. Basically, the sum should be odd. So that is also one of the approach. And one other approach is using the binary representation of these numbers. So 4 in binary is written as 100 and 3 in binary is written as 11. So basically, whatever are the two numbers that we are considering, their last bit has to be different. If the last bit is different, then that means one is even, one is odd. If both are 0 or both are 1, then that means both are even or both are odd, right? So here, so you can check that nums of I and 1. So this will give you the last bit, right? So if this is equals to nums of I minus 1 and 1, so then that means we need to return a false, both are even or both are odd, right? So this is how we can solve this problem. Now let's look at the code. So here what we will do is we will run a for loop of I starting from 1 and we will go till nums dot size and then we'll do I plus plus and then we will check that if nums of I modulo 2 is equals to nums of I minus 1 modulo 2, then we will return a false because this denotes that both are even or both are odd, and at the end here we can return a true. So let's run this. Now other way of doing is that we take the sum. So nums of I plus nums of I minus 1, their sum when done modulo with 2, if it is equals to 0, then that means both are even or both are odd. So we will return false. So let's run this one also. And the third approach is that we can check that nums of I and 1, if it is equals to nums of I minus 1 and 1, right? So basically if the last bit are same, then also we need to return a false. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.